Now we are going to use a list of 4 values to identify this limit. Okay. Again, I want you to recall the limit is determined by the values of x, so not equal to 0, to the left of 0. By that we mean so less than 0. Okay, and very close to 0, and getting closer and closer to 0. Anybody want to tell me a list of values? A list of values you want to choose in this column? These values are not equal to 0, very close to 0, less than 0, and getting closer and closer to 0. Okay. Choose some numbers very close to zeros. Yeah, the first number is okay. Okay, so negative 0.1. So maybe negative 0.01, negative 0.001. Okay, the next number, so maybe we use negative 0.0001. Okay, again, maybe negative 0.9 is good, but it's not too close to 0. Okay, so now let's say on number line you have the origin 0 in here. Okay, so negative 1 in here. We want to use a list of numbers getting closer and closer to 0. Probably you could start with any number like so negative 0.9. So but try to use the numbers getting closer and closer to 0, eventually very close to 0. Okay, like the numbers negative 0.0000 something. Okay. Okay, now let's agree these are the 4 numbers very close to 0, to the left of 0. By to the left of 0, I mean so less than 0. Try to use a number line to help you to understand the meaning of to the left or to the right. Okay, and then we are going to use a list of values to identify the limits. But before that, we evaluate the function at the 4 values. So please, now get your calculator, please. I want you to evaluate the function at negative 0.1. Yeah, probably I told you how to locate the button E on your calculator. So maybe you try to locate the button E first. Locate the button E first and try to compute the E to the power of 1. Locate the button E and try to compute the E to the power of 1. Now we are trying to practice the button. Okay. E to the power of 1, if you get 2.7 something, then most likely you have the right button. Okay. After getting the E button, I want you to evaluate this function at negative 0.1. So by that we mean I want you to compute E to the power of negative 0.1 minus 1 over 0.1. You replace x with 0.1. Okay, and then you evaluate the function. Most likely Brittany got the number right. Okay. Again, I'm going to wait you for a little longer to get me at least 1 value. As long as you can have 1 value, then you know how to identify all other values, how to evaluate the function at other values. Okay. So before the class, I did the calculation. Okay. Now take a look at the calculation. Okay. These are the numbers I chose. So do not worry about what calculator I'm using. I'm using R, a statistical software. It's a free one. So that's my calculator. Okay. The first number is 0.95 something. Then Brittany got it right. Yeah, the first number. Okay. These are the values of the function. Now you look at these values, the highlighted numbers. So these are the values of the function at the numbers negative 0.1, negative 0.01, negative 0.01, negative 0.0001. I think I said it right. Where I'm not asking you, we are not only calculating the value of the function at these numbers, we are trying to identify the limit. Now answer my question. Okay, we are trying to identify the limit. These are the numbers approaching 0 from the left. Now you look at the mouse cursor. These are the numbers approaching 0 from the left. And then you tell me what is the number, the values of the function approach to. Yeah, the limit is 1. Okay, the limit is 1. Okay, you see these are the numbers getting closer and closer to 1, eventually very close to 1, right? So we say the limit of the function. I hope it makes sense. We say, now you look at the mouse cursor, the limit of the function as x approaches 0 from the left, the limit of the function equals 1. Okay, the numbers are pretty long. I cannot memorize, but I told you the values of the function. Okay, you could put these values into the table, and then using the list of 4 values, we can identify the limit of the function e to the power of x minus 1 over x as x approaches 0 from the left. So this limit is equal to 1. So because the values of the function are getting closer and closer to 1. Right. You guys are okay? I did not put these 4 numbers in, but if you do want to copy the list of numbers, the list of 4 values of the functions on the screen. Actually, you do not have to. As long as you know how to evaluate, it's absolutely okay. You really do not have to. Okay. Can I move on? Okay, so can I ask you to take a look at so maybe that row. This row has the values of x to the right of 0. Can I say to the right of 0? To the right of 0, very close to 0 and getting closer and closer to 0. We say these are the numbers approaching 0, right? As x approaches 0 from the right, these are the values of the function at the numbers 0.1, 0.01, and so on. Okay. From these values, you can see the limit of the function as x approaches 0 from the right. The limit of the function is equal to 1 as well. So these are the numbers getting closer and closer to 1 as well, right? Again, you do not have to copy, but if you want, you can take a picture right now using your phone. You take a picture, okay? So you can put in the values later. I'm trying to say to identify the limit of the, I'm going to modify something from here. To identify the limit of the function as x approaches 0 from the right, we are going to use a list of 4 values. Now let's say 0.1. You do not have to write positive, but I'm trying to modify this. 0.1, 0.01, 0.001, 0.0001, right? We use a list of 4 values like this, right? And then we can get the function values. Okay. Again, the function values are listed in this row. If you want, you can take a picture. Okay. I'm trying to say the limit of the function as x approaches 0 from the right is also 1. Okay. It's also 1. The limit of the function as x approaches 0 from the right is also 1. Okay. Okay, now the last limit. We also want to evaluate the limit of the function. Okay. Anybody want to tell me the limit? The limit as x approaches 0. I'm trying to say the double underlined limit. The limit of the function e to the power of x minus 1 over x as x approaches 0. The limit is equal to 1 because we have computed the 2 one-sided limits, right? The limit as x approaches 0 from the right, the limit as x approaches 0 from the left. Both limits are 1. Okay, so the limit of the function as x approaches 0 is equal to 1. Again, to check that, you compare 2 one-sided limits to get the limit of the function as x approaches a number. you compare two one-sided limits. If the two one-sided limits are equal, then the limit is the same number. If the two one-sided limits are different, then you say the limit does not exist. So that's the proper term. Okay. So later on we are going to see a few functions at somewhere the limit does not exist. Okay, in the future I want you to memorize that. That's an important limit. I want you to memorize. I'm going to use the limit to illustrate many other things. Remember the limit, okay? Memorize the limit. We are going to use this limit today even, okay, to illustrate many other properties. Okay. Actually, the next important limit I want you to memorize is another one, okay? So maybe now let's try to identify two one-sided limits first. The limit of the function sine of x over x. Again, x, when we talk about any trig functions, x values are in radians. In calculus, we never use degree measurements. We always use radian measurement. Okay. Now we are going to identify the limit of that function sine of x over x as x approaches 0 from the, now let's say from the right first, okay. And then we are going to identify the limit of sine of x over x as x approaches 0 from the left. And then we are going to identify the limit of the function as x approaches 0. We just use one handy table. I'm not even asking you to evaluate the thing. I'm using a handy table. I'm using a handy table in here. Now you take a look at the table, okay? You take a look at the table. Now only look at the x values with positive signs. I mean the x values 1, 0.5, 0.25, 0.125, and so on. How can we describe these numbers? How can we describe the x values? X value of 1, 0.5, 0.25, 0.125. Do not look at the negative signs, only look at the positive signs. These are the numbers approaching 0 from the right, right? And then you observe x values. You observe the function values, okay? I'm trying to say you observe the value of sine of x over x. How do you describe these numbers? I mean the numbers in the column on the right. These are the numbers getting closer and closer to 1, right? These are the numbers getting closer and closer to 1. Using this table, I'm trying to say the limit of the function as x approaches 0 from the right, the limit is equal to 1. Okay. And likewise, if you only look at the negative signs, if you want, you can take a picture of the table. If you only look at the negative signs, the x values are getting closer and closer to 0 from the left, right? These are the numbers approaching 0 from the left. And then the function values are the same, getting closer and closer to 1, right? I'm trying to say the limit of the function as x approaches 0 from the left is also 1. From the first two equations, you'll see the two one-sided limits are equal to 1. So because the two one-sided limits are equal, right? So the limit of the function as x approaches 0 is equal to 1. Okay. That's another important limit I want you to memorize. Okay, I will put the other one together. Okay. Now I want you to memorize two important limits I'm going to use the two limits to illustrate many things. Using a table of let's say 4 values of the function or many values of the function, we have seen the two limits are true. Okay, memorize the two limits. We are going to use the two limits to illustrate many other things. Okay. Any questions about this? I believe as long as you know how to use a list of values to identify the limits, as long as you know how to evaluate functions, you should be okay. Okay. So we have identified two important limits. Okay. Okay, now look at part 2. So part 2 is another type of the question. Part 2 is also designed to understand the concept of limits. Okay. We'll go over a weird question first. And then we go back to how to use the graph of these two functions to identify the limits. Okay. Again, we'll go over a weird function first. So the following may not be too easy to understand for some of you guys, but we'll try to get over it. Okay. You do not have to care about the function value. The next question is in the nature that we are going to use the graph of the function to identify the limits. Again, the next question is in the nature that we are going to use the graph of a function to identify the limit. Okay. So most likely that's a piecewise defined function. It has many pieces. Okay. You have seen the meaning of piecewise defined function before, right? Or some people just say piecewise functions. Okay. I still prefer to say piecewise defined functions. Okay, now let's try to understand the function first. Okay. I hope you can see the graph properly. Okay. Now listen to my questions. Okay. I'm going to use the graph to understand the meanings of the questions. Anybody want to tell me the value of the function at 0? The value of the function at 0 using the graph? I'm trying to help you understand the meaning of piecewise defined functions. Okay. Yeah, 2.5 is right. 2.5 is kind of right. Okay. The value of the function at 0 is kind of 2.5. Okay. Anybody want to tell me the value of the function at 1? The value of the function at 1, please. The value of the function at 1. You locate the x coordinate of 1. Okay. And then you locate the corresponding point on the graph, and then you see the y coordinate of the point. The value of the function at 1 is 2. Okay. In class we mentioned a dot, a circle, right? If you have a hole, then it means the value of the function is not defined at that point. If you have a solid dot, then it means the value of the function is defined at that point. Okay, I don't really know about the black dot and the, how do you want to say this color? Orange, brown. Can I just say the brown dot? It's kind of brown, right? Okay, sorry, I told you I'm a little colorblind. Okay. The solid dot, it means a hole. Now look at the mouse cursor. Okay, this dot is a solid dot, corresponding to what we have seen in my sketch. Actually, a hole or dot is kind of it's kind of standard. I really think they could use a circle, a hole, or a solid dot for this. I'm trying to say what I'm trying to say. So anybody want to tell me the value of the function at 2? The value of the function at 2, please. The value of the function at 2 is not given by the black dot. The value of the function at 2 is given by 4. It's not 3. Sorry, so maybe I did not say it clear. You imagine the black dot is a hole, okay, a hole. This dot is a solid dot, okay. Okay. If you follow the curve, the function is the value of the function at 2 is not this. It's not this hole, okay. The value of the function at 2 is actually 4. So that makes sense? Okay. As long as you know that, then we can use this graph to understand the concept of limit. We're going to use the graph to understand the concept of limit using this graph. Okay. So the first limit we are going to identify. The first limit we are going to identify is the following. I'm going to write the limit on PowerPoint. Okay. Sorry, I forgot the graph. The first one we are going to identify is the limit of the function. Okay. I'm going to write the question. Okay. Now let's say use the graph of the function shown. The function I just showed you, okay, to identify limits. Now we're going to answer a few questions. So probably the first question is the value of the function at. Now I'm going to get the value of the function at 2 first. Okay, the value of the function at 2. Many of you guys told me the answer is 4. The answer is 4, right? Again, the value of the function at 2 is not given by this black dot. You imagine it's a hole in here, okay? The value of the function at 2 is given by the solid dot. So this is the solid dot, okay? The brown dot. Is this color brown or red? So anybody want to tell me the color, please? Is it red? The red dot is a solid dot, okay? So whatever color. Yeah, that's right. Yeah, sorry, I'm not totally colorblind, but I'm a little weak at colors. But you imagine it's a hole in here, it's a dot in here. Okay, so the value of the function at 2 is given by the dot. It's given by the y coordinate of the dot. It's not given by the y coordinate of the hole. Okay. All right. Now concentrate. Now something interesting or something might be a little bit hard for some of you guys is the following. Now we are going to identify the limit of the function as x approaches 2 from the right. We are going to use the graph of the function to identify the limits. Again, we are not going to use a list of values. We are going to use the graph to identify the limit of the function as x approaches 2 from the right. Okay. Where the graph is here. Okay. So do not tell me the answer right away. So anybody want to guess the answer? Now you look at the graph. So very shortly I'm going to make some comments. But if you can answer the question, if you can see the limit, then you don't need to listen to me. I'm going to make more comments soon. But can you see the limit? I will give you some hint. Okay, the limit of the I'm trying to ask you for the limit of the function as x approaches 2 from the right. Now look at the mouse cursor. You imagine x value is approaching to 2 from the right. x value is approaching to 2 from the right. And then you identify as x approaches 2 from the right. As x, the limit of the function is determined by the values of the function to the right of 2, not equal to 2 and very close to 2. When x approaches 2 from the right, you identify the values of the function approach what number. That number is the limit. X cannot be 2, x has to be to the right of 2x. It's getting closer and closer to 2. As x approaches 2 from the right, what's the limit of the function as x approaches 2 from the right? Try something, please. Try something. So don't be scared. It's okay to make mistakes. Yeah, 4 is right. Actually, 4 is right. 4 is right. Okay. Okay. Now listen to me carefully. 4 is right, actually. Okay. That's why I like this graph. It shows me the coordinates, actually, when I follow the curve. You look at x coordinate only. You look at x coordinate only. Okay. You look at x coordinate only. Okay. We want x to be greater than 2. You cannot put the x value in here. X has to be a number greater than 2, right? And very close to 2. Not equal to 2, cannot be equal to 2, okay? And getting closer and closer to 2. Now you look at the screen. Okay? As x gets closer and closer to 2 from the right. As x gets closer and closer to 2 from the right, you look at x values only, okay? I'm making x value getting closer and closer to 2, right? And then you look at the values of the function. The values of the function is given by the y coordinate of the point. So that makes sense? You make x not equal to 2, very close to 2, getting closer and closer to 2. And then you observe the values of the function. The values of the function are getting closer and closer to what number? You look at the y coordinates. You look at the change of the y coordinate. The y coordinate gets closer and closer to 4. Does that make sense? Okay. I will do that again, okay? Now you take x value to the right of 2, very close to 2. And then each value of x so determines a point on the curve, right? So the point on the curve determined by x value of 2.22 is kind of here, right? And then you make x gets closer and closer to 2 from the right. And then you observe the change of the y coordinates, okay? Y coordinates are getting closer and closer to 4. I want you to remember this point. X value can never be 2. Now you remember the limit is determined by the values of the function not equal to 2, right? Y values are getting closer and closer to 4. That's the limit, okay? Actually, I really hope you do not need the y coordinates to do that, okay? It's possible for this curve, but it's not possible for many other curves. Can we agree the limit of the function as x approaches 2 from the right, the limit of the function equals 4? If you have no problem with that, then any questions about this? I can repeat. So just remember the 4 things I told you, okay? The limit is determined by the values of the function to the right of 2 in this particular case. Very close to 2 and getting closer and closer to 2. Not equal to 2, of course, right? Okay, now we are going to identify the limit of the function as x approaches 2 from the left. The same function. That's piecewise defined function. Okay, I will show the graph. Anybody want to tell me the limit? So tell me the limit, please. This time x value has to be, now you look at the mouse cursor, has to be to the left of 2, less than 2. not equal to 2 and getting closer and closer to 2, right? Very close to 2. 3 looks right. The limit is 3 looks right. I think all of you guys got it. All of you guys got it, okay? And the limit is 3, okay? Again, if you are given a graph, in most cases, you cannot do this. I just found out the website. It's quite interesting. I told you, you look at here. So decimals, it's pretty interesting actually. So people have been doing so many interesting things about that. Okay, again, you take x values to the left of 2. I mean less than 2. Okay, very close to 2, not equal to 2, and getting closer and closer to 2. Okay, although the function is not although the value of the function at 2 is, I really do not like this, undefined. The function is defined at 2. The value of the function at 2 is this 4. Okay, but it's okay. You see the meaning. Okay, as x gets closer and closer to 2 from the left, the values of the function gets closer and closer to 3. I think you have seen it. Okay, now you just remember the limit has nothing to do with the value of the function at 2. Now we are going to write the limit. I know this is one of the hard points for some of you guys. It's normal. Every year, a few people could have problems with this, but I found out the decimals can do this. It's probably easier to understand this way. So the limit of the function as x approaches 2 from the right is equal to, you told me, 3, right? So don't be shy if you have any questions. Okay. If you have a questions, I can go over the thing in some more details. If you don't have any questions, do you have any questions? As long as you know how to get the 3, you should be okay. I will take that as no. Okay. Actually, I know some instructors ask people to turn on cameras, so it's probably okay idea, but it could slow down internet. Okay, it's okay. We'll still keep on doing this. So we have seen 2 one-sided limits. We have seen the value of the function at 2, right? And then I'm going to ask you one additional question. How do you answer the following question? How do you tell me the answer to the following question? I'm also asking you for the limit of the function as x approaches 2. Anybody want to tell me the limit? Yeah, probably I wrote something wrong in here. Okay, does not exist. Does not exist. Okay, does not exist. Or you can just say DNE. Does not exist is right. Okay. So this is the first question you have seen. The limit of the function does not exist. Okay. Try not to say undefined. But if you say undefined, it's okay. But there's a difference between the two terms, undefined and does not exist. It means it's possible to define the limit of the function at a number, but in this case, the 2 one-sided limits are different. So you say does not exist. Okay. The bottom line is try to remember how to say it properly. Okay. Actually, probably 2 is a pretty interesting point. Okay. And then very quickly we are going to go over some other limit. So can I add one more line? Yeah, probably it's possible for me to add one more line. I'm sure I can add one more line. Okay, I'm going to add, I don't know, this point. I think this point is x value of -1. So give me one little moment. I hope it can let me do this. I'm going to zoom out. You kind of see the curve. Okay. X value here is -1. Now for x value of -1, where I'm going to ask you a few questions. Okay. For the function, so anybody want to tell me the value of the function at -1? The function f I'm talking about is the function on the screen. Anybody want to tell me the value of the function at -1? And by the way, the blue line I added is not part of the graph. It's not part of the graph. I was adding the graph to show you this line is a vertical asymptote. Anybody using the graph of the function? Anybody want to tell me the value of the function at -1? At this number? Undefined. Undefined. The function is undefined at -1. Okay. This thing is undefined. Okay. Actually, I did not mention the concept earlier, but I hope it's not too hard to understand. The next limit we are going to talk about is the limit of the function as x approaches -1 from the right. That's the next limit. The next limit we are going to identify using the graph of the function. Okay. Again, the limit is determined by the values of the function to the right of -1, very close to -1, not equal to -1, and closer and closer to -1. I'm going to follow the curve. Okay. I'm going to make x value to the right of -1 not equal to -1, getting closer and closer to -1. Okay. Can I follow this curve? I'm pretty sure I can. Now you look at x coordinate. I start with -4.7 something. Okay. I'm going to make x coordinate getting closer and closer to -1. You see, you observe x coordinates. Okay. You observe x coordinates of the point. These are the numbers getting closer and closer to -1. Okay. Anybody want to describe how the y value changes? How the y value changes as x approaches -1 from the right? How the y value changes? If I zoom out more, you could see something like this. So do you see something like this? Y value gets larger and larger positive, right? So do you know what I mean? I'm trying to say when you make x value to be a number very, very close to -1, y value can be very gigantic, can be any large. Again, I want to repeat the behavior of the function as x gets closer and closer to -1 from the right. As x approaches -1 from the right, the function values gets larger and larger positive. Get larger and larger positive, right? Can be as large as possible, as large as can be. And then we say the limit. Okay. Anybody want to guess how to answer the question? How do you want to tell me the limit? As x approaches -1 from the right, the value of the function can be any large, can be as large as can be. How do you want to tell me the limit of the function as x approaches -1 from the right? Infinity. That's something I'm looking for. Okay, that's the real infinity. That's real infinity. It means the value of the function can be as large as possible, as large as can be. Okay. When you choose a point very close to -1, very, very close to -1, it can be so -10,000. It can be so -1 million. As large as can be. You know what I mean, right? So we use this notation to indicate the behavior of the function. We say the limit of the function as x approaches -1 from the right equals infinity. Okay. One more. One more, the limit of the function as x approaches -1 from the left. Anybody want to tell me the limit of this limit right away, please? Now we are talking about the limit of the function as x approaches -1 from the left. So -1 is here. Yeah, negative infinity. Okay, negative infinity. In this course, we do differentiate two infinities. So the limit of the function as x approaches -1 from the right is negative infinity. Okay. Okay. Now the two one-sided limits are different. One is positive infinity, the other one is negative infinity. And then we say the limit of the function as x approaches 1. We say the limit does not exist. Okay. Okay, now you can take a picture of the graph. So these are probably all the questions I want to go over for this question, for this graph. Now you can take a picture of the graph, or alternatively you Google how I found the graph. You Google that. So Desmos piecewise functions. If you search that, this graph will come up. You see the same graph, right? It's kind of interesting. Okay. Any questions about this? If you don't have any questions, I want to go over some questions on textbook. That's one of the questions on the textbook. Okay. So this time, the author was trying to use some circles and dots, the same convention as mine. It's kind of standard in math. Now you look at the graph of the function. Okay. We're going to identify a few limits. We're going to identify a few limits using the graph. So this time I hope you could answer my questions. Okay, write your answer in the chat, please. Okay. I'm going to call this function f of x. Probably I cannot. The graph is the function y equals f of x. Okay. So tell me the value of the function at -2. So we'll do that part first. The value of the function at -2, please. The value of the function at -2. You look at the mouse cursor. So -2 is here. It's 8. It's 8, corresponding to -2. This point is a hole, right? That point is a hole. That's a solid dot. The value of the function is given by the y coordinate of the dot. So the value of the function at -2 is 8. Very quickly, anybody want to tell me the limit of the function as x approaches -2 from the right? Now let's do the right hand side limit first. Okay, as x approaches -2 from the right. Again, I'm looking for the limit of the function as x approaches -2 from the right. Yeah, 2 is right. You look at the mouse cursor. Okay, you follow that curve. As x gets closer and closer to -2 from the right, as x approaches -2 from the right, you follow that curve. The values of the function get closer and closer to 2. I hope after the other question it should be simpler. So the limit of the function as x approaches -2 from the right is equal to 2. It's given by the y coordinate of that hole. Okay. And then anybody want to tell me the limit of the function as x approaches 2 from the left? approaches 2 from the left, please. This time you just follow that line, right? It's 6, so 6 is right. Okay. And then, so this time you see these three numbers are all different. The value of the function at -2, the limit of the function as x approaches -2 from the right, approaches -2 from the left. These three numbers are all different, right? You see 8, 2, 6 are all different. So by that we mean, now listen to me, by that we mean the limit of the function has nothing to do with the value of the function. In this particular case, the limit of the function as x approaches -2 has nothing to do with the value of the function at 2. Okay, and then one more question I want you to identify. The limit of the function, I mean the limit of the function as x approaches 2, approaches -2, I mean, sorry, approaches -2. Approaches -2. Does not exist, right? Does not exist. So because two one-sided limits are different. Okay. Anybody need more questions? We could repeat the same thing for some other points. I could replace -2 with some other points. But if you have no trouble with this, then you should be fine. You should be okay. Anybody want me to go over more questions like this? That's essentially how to use the graph of the function to identify a limit. Okay. As in some cases, as long as you know how to graph a function, then you should know how to identify the limits. All right. We'll do one more question in that nature, and then we are done. We're done this thing. Okay. Okay, we'll do one more question like this. So this time, the difference is that I give you the definition of the function. The first thing I want you to do is to sketch the graph, to graph the function. Okay. After graphing the function, I want you to use the graph to identify the limits. I know you did this question in class. No, you did this question for the assignment, right? But the difference is this time I want you to use the graph of the function to identify the limits, okay? Not using a list of values. Okay. I think we have seen the graph of the function a few times already. I will help you to recall the graph. I'm pretty sure I have the graph of the function somewhere. Okay. Okay, now look at the screen. On the screen, you have the graph of the function. I think you have seen the graph of the function a few times already. For handout 1, we sketched the graph of the piecewise defined function. Now let's recall some details. Okay. To the right of 1 and including 1, you have part of the parabola. The parabola has the equation y equals x squared, right? And to the left of 1 and not including 1, you have part of a straight line. I believe the straight line has the equation y equals 2x. Okay. Now you go back to the definition of the function. You go back to the definition of the function and look at the graph of the function again. We have the graph of the function. Okay. And by the way, if you know, I'm trying to say you really should know how to sketch the graph of a function like this. You know how to sketch the parabola, right? The piece to the right of 1 and including 1 is part of that parabola. Now you follow the mouse cursor. And to the left of 1 is part of the straight line. The straight line has the equation y equals 2x. I think the slope is 2. The slope is 2, right? We have seen the graph before, right? Now we are going to use the graph of the function to identify the limit. Okay. We're going to fill in blanks very shortly, but now let's concentrate on the graph. Okay. So anybody want to tell me the value of the function at 1? The value of the function at 1, please. So that's supposed to be a solid dot. That's supposed to be a circle. The value of the function at 1, please, is equal to 1. And the limit of the function as x approaches 1 from the right, please. The limit of the function as x approaches 1 from the right is 1. Okay. The limit of the function as x approaches 1 from the left. The limit of the function as x approaches 1 from the left. You follow that branch, right? It's 2. Okay. Okay. I guess after the first question, you really got it. You guys really got it. Again, if you don't get it, so let me know. I can repeat. So this thing is kind of designed to understand the concept of limit. Okay. Now the solution, we just go over the answers. Okay. I think the value of the function at 1, you told me is 1, I believe. The limit of the function as x approaches 1 from the right is equal to 1, I believe. Right. The limit of the function as x approaches 1 from the left is equal to 2. The limit of the function as x approaches 1 does not exist. For the next assignment, I'm going to ask you to sketch the graph of some functions, a few functions, okay, and then you're supposed to identify the limits. We'll do one more and then we take a break. Okay. This is the point testing your high school math, or if you can remember things we reviewed in the first week. Now we're going to use the graph of the function to identify that limit. At this point, I want you to visualize the graph of the function natural log of x. If you can visualize, then you should be okay. If you cannot visualize, then try not to forget what we reviewed. Okay. So this time I'm going to get the graph of the function natural log of x. I'm going to open a new tab. Okay, the graph of the function is something like that. This is the graph of natural log of x. Okay. Using, I'll repeat again, on assignment 3, you are going to see questions like the following. Okay, I ask you to sketch the graph of the function. In some cases, I ask you to sketch the graph of piecewise defined functions, and then you identify the limit. Okay, so that's the graph of natural log. We are trying to get the limit of the function as x approaches 0 from the right. You follow that curve, right? Making x gets closer and closer to 0 from the right, getting tinier and tinier. Anybody want to tell me the limit? If I zoom I zoom out. Anybody want to tell me the limit? The negative infinity. Okay, you follow that curve as x gets closer and closer to 0. I lost the points. As x gets closer and closer to 0 from the right, the value of the function can be as large negative as can be, right? If you want negative 10,000, then you have negative 10,000, as long as x value is sufficiently close to 0 from the right. That shows the limit of the function as x approaches 0 from the right is equal to negative infinity. Okay, I'm going to write the answer to this question. Okay, negative infinity. Okay, property number 7. Property number 7. Now let's try to see that. Okay. Now let's say if I want you to compute the limit of the function 5 as x approaches, so now let's say 2. Using the graph, now we try to use the graph of the function to identify the limit. You know 5 is a constant function, right? The constant of 5 is something like that. So now let's say 5 is here. Y equals 5 is a constant function. The graph of the function is a horizontal line. Okay. If I want you to identify the limit of the function as x approaches 2, so now let's say 2 is here, 2 is here. I think you see the two one-sided limits. Now let's talk about the right-hand side limit first. Okay. To get the right-hand side limit, you take x value very close to 2, not equal to 2, and getting closer and closer to 2, right? And then you identify the limit. So anybody want to tell me the limit of the function y equals 2 as x approaches 2 from the right? The limit is 5. You see it on the graph. Actually, the two one-sided limits are both 5. You see the limit of the function as x approaches 2 is equal to 5, right? 5 is a constant function. Actually, it's true in general. It's true in general. Now property number 7, it says the limit of a constant function as x approaches whatever number a, the limit value is c. Okay, so I told you why that property is true. You just remember the limit of a constant function is the constant, no matter x approaches what number. So did I make it clear? Actually, for property 8, 9, and 10, and 12, so not 11 yet, not 11. For all these properties, I'm going to summarize all these properties. Actually, it's also true for number 7, using one theorem. Okay, I'm going to write the conclusion on the screen. I will illustrate the meaning using some particular questions. Okay. So copy it down. Okay, copy it on your notes. Okay. I'm going to call it a theorem. You remember we defined the building blocks of all the functions we need, basic elementary functions, and after performing addition, subtraction, multiplication, division, and composition operations, and then we have elementary functions, right? I told you the bottom line to remember. An elementary function is a function that can be written using one formula. Okay, that's where I need a conclusion here. Okay, so maybe you are given a function defined at a number a. Now let's say let f of x be a function, be an elementary function. Again, so by that we mean intuitively you just remember the function can be written using one formula. Okay, if the function is an elementary function, the function can be built using constant functions, power functions, exponential functions, log functions, trig functions, inverse trig functions, and so on. Right? It's an elementary function. Actually, two conditions. You need to make sure the function is elementary function. In particular, the function is not piecewise defined. Okay. Actually, the other condition is I should have written two conditions, but it's okay. So define that x value of a. Actually, I want you to see there are two conditions. One condition is the function is elementary. The other condition is the function is defined at a. If that is true, and then to evaluate the function, the limit of the elementary function as x approaches a, all we need is to the limit of the function as x approaches a is equal to the value of the function at a. Again, I want to repeat the conclusion. The equation is true under two conditions. One condition is the function can be written using one formula, to put this simply. The other condition is the function is defined at a. And then to evaluate the function as x approaches a, all we need is to plug a into the function, and then you can have the answer. I will show you how to use it using some particular questions. Okay. Okay, now let's work on question 3, on part 4, question 3 on the handout. Okay. Again, I give you a formula. The formula is true under two conditions. You have to make sure you verify the two conditions. At least you see the two conditions. For this course, you do not have to write down anything saying you have verified. But now you do need to make sure the conditions are true. Okay. In this particular case, the function is a rational function. Actually, the rational function is two polynomials. You do not have to know the term. But you do not have to know the term for now. So later on, you need the term later. Okay. Now the function we are talking about is a function. Now let's say 2 times x plus 1 to the power of 50, and then the denominator you have something. Something wrong with my mouse. Something wrong with the PowerPoint. And then the denominator is x minus 1 to the power of 100. This function is elementary. So because this function can be written using one formula, right? No matter how complicated, I told you a little trick before. As long as a function can be written using one formula, then the function is elementary. Okay. And then we are trying to evaluate the limit of the function as x approaches 0. The other condition is a function so defined as 0. That's why we talk about the domain of the function before. The function is only undefined at 1. So that makes sense? 1 will make the denominator 0. The function is only undefined at 1. In particular, the function is elementary, so defined at 0. In this case, to get the limit of the function, all we need is to do what? All we need is to plug the value a, the value of 0 into the function. If I'm using f to denote the function, the limit of the function is given by the value of the function as 0. You plug 0 into the function. Anybody want to tell me the answer? Actually, I'm going to write something in more detail. Okay, you plug 0. The limit of the function is given by the value of the function as 0, because the function is defined as 0 and the function is elementary. Okay, so you evaluate 2 times 0 plus 1 to the power of 100. You plug x, you replace x value with 0. Okay, and then to the power of 50, and then on denominator you have 0 minus 1 to the power of 100. Okay. Anybody want to tell me the final answer to this? It looks complicated, but it's super easy. In that brackets, you have 1, right? You have 1 to the power 50. 1 to the power 50 is equal to 1. On denominator, you have 1, so the final answer is 2. Okay. Simple, right? Again, two conditions. Check two conditions. One condition is the function can be written using one formula, but that more precisely the function is elementary. The other condition is the function is defined at this number a. In this particular case, a value is 0. In this case, to evaluate the limit of the function, all we need is to plug 0 into the function. You can have the limit. Okay. Simple question. Okay, I'm going to show you one more example, okay? Anybody want to tell me very quickly how to get the limit of the function as x approaches, let's say half pi? The function this time is sine of x. If you want more details, the function is elementary, that can be written using one formula, right? The function is defined at all numbers. In particular, the function is defined at half pi. Now to get the limit of the function at half pi, all we need is to plug half pi into the function. You evaluate sine of half pi, right? Do you remember the value of the function sine at half pi, sine of half pi? Recall the graph of the function. This is really commonly used trig value. Sine of 0 is 0, sine of half pi equals 1, right? You know that. Okay, I showed you two particular questions using the conclusion. Actually, using that conclusion, using the theorem, you can handle many limits. Quite many limits. Okay. But the class has been quiet for a little while. So can you guys hear me? Actually, last Friday my internet has problem. Last Friday I think my internet had a big problem, so people cannot hear me, cannot see me, cannot see the screen. Okay, and then I'm going to go over some properties one by one. Go over the properties one by one. Okay, some other properties one by one. Now look at property number 1. Property number 1, it says, if you want to remember how we say it, it says the limit of the sum of two functions is the sum of two limits. Okay, I will illustrate how to use the property. We are not going to prove the property. It's not too hard to. Actually, it's hard for you guys to prove. I'm trying to say the proof is not required. If you want to do math major, you look at the textbook. If you don't want to do the math major, it's okay. So just know how to use the properties. Okay. I will use one particular question to illustrate how to use the property. Okay. Now, for instance, if I ask you to evaluate the limit of the function, so now let's say sine of x over x, sine of x over x, and then plus e to the power of x as x approaches 0. Now the first question is it okay to use that conclusion, to use the equation in here? Is it okay to use the equation? By that we mean, is it okay to plug 0 into the function to get the limit? Actually, it's not okay. Now, to use the equation, we have to check two conditions. One condition is the function is elementary, so no problem with that. Okay, the function can be written using one formula. But is the function defined as 0? The function is undefined as 0. You look at the mouse cursor. the x value of 0 will make the denominator of that term 0, right? So the function is undefined at 0. So you cannot plug 0 in to get the limit. Okay, that's where we have to use the property of the limit. Okay. To use the property of limit, can I label this using number 1? I'm trying to say I could cross the line. Property. So question number 1, I'm going over here, is corresponding to property number 1. Okay, but I will try to write everything on this line. To use the limit of the sum of two functions is the sum of two limits. So by that we mean you treat the first function as f, you treat the second function as g. Now we're trying to compute the sum of two limits. The first limit is the limit of sine of x over x, and then the second limit is the limit of e to the power of x as x approaches 0. Okay. Anybody want to tell me the answer to the first limit? The answer to the first limit, please. As x approaches 0, sine of x over x. It's 1. I told you to memorize. At the beginning of the class, I told you to memorize two limits, right? One of the two limits is that. I told you I was going to use the two limits to illustrate some properties. That's where I need the two limits. Okay. The first limit is 1. Anybody want to tell me the answer to the second limit? E to the power of x is elementary. To get the limit of e to the power of x as x approaches 0, all we need is to plug 0 into the function e to the power of 1, right? Sorry, e to the power of 0. Plug 0 into the function, you have e to the power of 0. That's not the final answer. It's super easy to compute e to the power of 0 to get the value of e to the power of 0. E to the power of 0 is equal to 1, right? And then you have 1 plus 1, so the final answer is 2. Okay. Again, my intention is to use a question like that to illustrate property number 1. Okay. Any questions about that? If you don't have any questions, if you know what's going on with question 1, you should be able to do question number 2. Okay, you know the meaning of 2. I mean property number 2. Okay, property number 2. If you want me to say it in words, it's the limit of the difference between two functions. The difference is the answer to subtraction, right? The limit of the difference between two functions is the difference between two limits. So try to remember the properties. Okay. We'll skip property number 2. Probably I'm going to use a particular question to illustrate property number 3. Okay. In question number 3, c is a number. I will label a question using number 3 corresponding to property number 3. Okay. If I want you to evaluate the limit of the function, so now let's say 3 sine of x over x as x approaches 0. In this case, you cannot plug 0 in to get the limit, so because the function is undefined, right? You have to do something. You see 3 is a constant c. Whenever you see a number, you can leave the number out of the limit notation. It's kind of saying that. You leave 3 out of the limit notation. You have 3 times the limit as x approaches 0 sine of x over x. Now the limit part is equal to 1. So the final answer is 3 times 1, right? So you have 3. Okay. Again, my intention is to show you what are the meanings of the property and showing you how to use the properties using some particular questions. Okay. If you know the meaning of property number 1, property number 2, property number 3, then the meaning of 4 should be simple too. Okay. You just replace addition with a multiplication. Property number 4 says the limit of the product of two functions. The product is the answer to a multiplication. The limit of the product of two functions, you follow the mouse cursor, okay, is equal to the product of two limits. And likewise, the limit of the quotient of two functions is equal to the quotient of two limits. Okay. Now for number 6, so probably I'm going to show you a question illustrating property number 6. Okay. I will show you a question illustrating property number 6. So how about we do this? As x approaches 0, if I want you to evaluate the limit of the following function, so now let's say x squared on denominator, on numerator you have e to the power of x and the minus 1 the whole thing squared. If I want you to evaluate that limit, you see this form is kind of very close to the form in property number 6. You just need to do a little bit more conversion. I want you to recall a property you learned in high school. In general, a over b the whole thing to some power, to whatever power, in particular squared. In this case, we just need squared, right? A over b the whole thing squared is equal to a squared over b squared. Right? You learned that property in high school. Exponent, probably you learned that in pre-calculus 11, if I remember correctly. And by the way, okay, we use that property, we can convert the limit to the following form, to the form of, now let's say, the limit as x approaches 0. You use the property the other way around, from the right hand side to the left hand side. So we are trying to get the limit of the function e to the power of x minus 1 over x, now the whole thing squared, right? Can you follow me? I was just trying to use that property, the top property, the other way around. We do not have a handy formula for that limit. We cannot plug 0 in to get the limit because the function is undefined at 0. You see the denominator has x, right? But now we can use property number 6. You take n value of 2. You treat n to be 2 in the question, okay? You use that property, you can get the limit as x approaches 0, the function now is e to the power of x or minus 1 over x. Okay. Now the whole thing squared. So do you want to compare the question I'm doing with property number 6? N value is 2. From the left hand side, you have the last equation, right? The inside limit, the limit inside the brackets, I told you to memorize the limit. The other important limit, I told you to memorize. This limit is 1, so the whole thing is going to be 1 squared, so which is 1. That question is designed to illustrate how to use property number 6, or the meaning of property number 6. Okay. So later on we are going to go over a little bit more complicated question combining many properties. But before that, I'm going to use a particular question to illustrate property number 11. I will just squeeze it here. Now property number 11, I'm going to use a particular question to show you the meaning. So maybe a simple question, okay? So maybe the limit of, now the function is sine of x over x. Actually, I do not have too many interesting questions to make convincing questions. So maybe square root of that, square root of that function, sine of x over x, as x approaches 1. So now let's do that. Okay. Sorry, as x approaches 0. I mean 0. Okay. For 1, you can just plug in. For 0, you cannot plug in to get the limit. The function is undefined at 0, right? Okay, now I'm going to use property number 11. The limit goes into the radical. You look at property number 11. It's kind of the limit can go into the radical, right? Now look at the limit inside the radical. Okay, the limit inside the radical is the important limit. It's 1. So you have square root of 1. The final answer is 1. Okay, I just told you the meanings of all these properties from property number 1 to number 12. Okay. Now I will show you a question. A little harder question, okay? Showing you how to combine all these properties. For the assignment question, I'm going to ask you to apply only one property, only one limit property in every step. I'm trying to say, so do not just give me the final answer. I'm asking you to apply only one limit law, okay, limit property in every step. Okay, the first property I want to apply is number 11. Okay, I think you have copied all the properties. I do not have to go back to the screen. I'm trying to say the first property I want to apply is to put the limit notation inside the radical, inside the square root. Again, I'm trying to apply only one property in every step. The first property I'm using is property number 11, which says you can put the limit notation inside the radical. Sorry, I lost my voice. I think I'm okay now. Okay. For the limit notation inside the radical. For the limit notation inside the radical, you have the limit as x goes to 0. That's property number 11. Okay. And then the entire function is 10 e to the power of x minus 10, and then over x minus natural log of e minus x. And then inside the radical, inside the square root or under the square root, you have the limit of the difference between two functions. We're going to use property number 2. Property number 2 says the limit of the difference between two functions is the difference between two limits. I know this part is a little boring, but I have to mention some properties before we can do interesting questions. You kind of distribute the limit notation into these two functions. And by the way, the reason we have to do this way is the given function is undefined at 0. You cannot just plug 0 into the function to get the limit. You cannot do that because the function is undefined at 0, right? Again, I'm trying to apply only one property in every step. So the next step I'm going to do is to use the property to leave the constant factor 10 out of the limit notation. You have 10 times. So do you see a common factor of 10? You take 10 out of the two terms, and then you take 10 out of the limit notation, right? It's permissible by property number 3, I believe. So just copy it down, and then you compare the properties. Okay. We're almost done. We're almost done. I think I can get everything done in here. Now follow the mouse cursor. Now you look at this limit, okay? You look at this limit. That's an important limit I told you to memorize. The answer to that limit is equal to 1. You look at the mouse cursor. So now we are ready to get the final answer. Almost ready to get the final answer. So you have 10 times 1, right? Minus, how can we get the second limit? The second limit, this function is defined as 0. So we just plug 0 in to get the limit. I'm trying to say the second limit. The second limit under the radical is equal to natural log of e, right? You replace x with 0, you have e, right? That's not the final answer yet. Natural log of e is equal to 1. You know that. Okay. So you have 10 minus 1. So the final answer is square root of 9. Final answer is 3. Okay. Again, on your assignment, you are going to see a question like this. So do not just give me from the first step to the last step. I would specify. I think I'm going to specify, if I remember. I'm going to specify to apply only one limit property in every step. Okay, so that's how you show your work. Any questions about this? I think you need a little bit longer to digest that. But next week it's reading break. You are going to have a long time to digest that. I don't think anybody is traveling this at this time. These are all the basic properties I want to mention. And then using the basic properties, we can do many other questions. We can do many additional questions. Now probably we can go over 2 more questions. Now let's do number 4. Question 4 is simple. Now look at the limit. Is the function defined as 0? The function can be written using one formula, no problem. The function is only undefined at 2, right? In particular, the function is defined as 0. In this case, you do not need to use any other techniques. The only thing you need to do is to plug 0 into the function. I will show you how to do that. Okay. You do not have to write the 2 conditions are satisfied, but you do need to check the 2 conditions. Okay. The function can be written using one formula. The other condition is the function is defined as 0. The 2 conditions are both true. In this case, to get the limit, all we need is to plug 0 into the function. Replace x with 0. Okay. You have 0 squared minus 4 and 0 minus 2. This time you have, I think, negative 4 divided by negative 2, you have 2. Is that right? Okay. That's a simple question. Okay, not all questions are that straightforward. Now look at number 5. I will let you go home after this. So you're home. Now look at question number 5. The same function, but we take the limit as x approaches a different number. This time approaches 2. For this question, is it okay to plug 2 into the function to get the value of the limit? We can't. We cannot. Why? The function is undefined at 2, right? 2 will make the denominator 0. So you cannot do that. You cannot plug 2 into the function to get the limit. Anybody want to tell me what to do? Want to guess what to do? Anybody want to guess what to do? Please. Actually, in the function x minus 2 is a bad egg. So can I just say a bad egg? So because x minus 2 is equal to 0 when x value is 2. So the function is undefined at 2. We want to do something to get rid of the bad egg. What can we do? Factor. Okay. So next time I'm going to summarize. But this time the technique we're going to use is to factor. Factor the numerator and factor the denominator. Okay. To factor the numerator, I want you to recall one formula. You learned that in whatever grade. It's probably a long time ago. How to factor a squared minus b squared? You have a minus b times a plus b. Okay. I'm trying to review as much as possible from your high school math. Okay. Copy the limit notation. That's actually a common mistake. Copy the limit notation. Okay. You do need to copy the limit notation all the way. And then there's nothing you can do about the denominator. You have x minus 2, right? Now you treat 4 as 2 squared. On the top you have the form of a squared minus b squared, x squared minus 2 squared. Using that formula you have, what do you have? You have a minus b times a plus b. In this case you have x minus 2 times x plus 2, right? After that, we can cancel out the bad egg. So, but remember, to cancel out something from the numerator and the denominator, you do need to make sure the factor you want to cancel out is not equal to 0. Why is x minus 2 not 0? When taking the limit, we treat x as a number very close to 2 but not equal to 2. Right? When x is not equal to 2, x minus 2 is not equal to 0. That's why we can cancel out a non-zero factor. Okay. There's a little bit long story in here. Cancel out x minus 2. I will write one more step. So just it's possible to get the final answer, but I'm going to show you one more step. Okay. After canceling out x minus 2, you have the limit as x approaches 2, there remains x plus 2 only. Okay. Now the function is elementary. You can plug 2 into the function. I mean the function now is defined at 2. Okay. To get the value of the limit, you just plug 2 into the function. If you want one more step, you have 2 plus 2, and then the answer is 4. Okay, so that's a question designed to show you a technique for evaluating the limit. The first technique you remember is to factor. Okay,